Hi students, in this video I'll be recapping about trigonometric ratios using two questions. Okay, so the first question will be a easier one, and then the second question will be a slightly more challenging one. Alright. Okay, so let's start off with the first question. So given that tangent B is equals to negative half and that B is greater than 90 but less than 270, find each of the following without using a calculator. Right, so for such questions, we always need to draw the triangle first, okay? So use your ruler, okay? So you can draw straight lines on your paper, okay, to draw the four quadrants. Okay, so over here, if you recall, this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. Okay, so assuming the angle is now theta, okay? So in the first quadrant, the angle is between 0 to 90, all right? So in the second quadrant, the angle is between 90 degrees to 180 degrees, right? And in the third quadrant, the angle will be between 180 degrees to 270 degrees. And then finally, in the fourth quadrant, the angle will be between 270 to 360 degrees. Okay, so these are the four quadrants over here. Okay, so since they say that B is greater than 90 and less than 270, that means B is either in the second or third quadrant. Okay, so later on we will need to decide which quadrant is actually inside now. Okay, so if you recall also, these four quadrants, we call them A, S, T, and then finally C. Okay, so why do we call them A, S, T, C? So A stands for all, right? Okay, so in the first quadrant, all the three trigo ratios, sine, cosine, and tangent will be positive. And in the S quadrant, only sine will be positive, so cosine and tangent will be negative. Then in the third quadrant, sine and cosine will be negative, only tangent is positive. And finally, in the fourth quadrant, only cosine is positive. The other two trigo ratios are negative. All right, that's why we call it C. All right, so now you can see over here that the tangent is negative. Okay, so if tangent is negative, then remember just now we were saying that it's either in the second or third quadrant, right? 90 to 270. But since now tangent is negative, then we can rule out the third quadrant already, because if angle B is in the third quadrant, then tangent, the ratio tangent B should be positive. So this means that B is now we know for sure that it's in the second quadrant. So now we can draw the triangle in the second quadrant, okay? So that triangle will be here. Okay, so do you recall where angle B is? So angle B is not over here. Okay, this is not B, all right? Angle B is over here. Okay, so the general angle always starts from the positive x-axis, okay, to the line stopping the angle, right? So angle B is over here. Okay, so if you recall, tangent, okay, the basic idea behind tangent is that tangent is the trigo ratio of opposite over adjacent, right? Okay, that means now the angle is over here. This will be the opposite side. Okay, this is the O and this is the A. Right, so O over A is now negative 1 over 2. Okay, but which one is negative? Is it the opposite that is negative or the adjacent is negative? Okay, it cannot be both negative. If both are negative, then negative over negative should give me a positive ratio, right? Okay, so in this case, you should realize that this one is the positive one, 1, and this is negative 2. Okay, why? Because over here, this is in the positive y-axis region. So this is the y-axis, this is the x-axis. This is the positive y-axis region. Whereas this one over here is the negative x-axis region. Okay, this one is the positive y. So the number over here, the adjacent should now be negative. All right. Okay, so the next thing to do is to find out this hypotenuse. So how to find out the hypotenuse? We can easily use Pythagoras theorem, right? So hypotenuse will be equals to square root 1 square plus negative 2 square. Okay, so that will give you square root 5. So this hypotenuse over here, the value is square root 5. Okay, so once you get all these three values out, it's actually very easy to get all these answers ready. Okay, so for example, in part 1, you want to find secant B, right? So if you recall, secant is 1 over cosine. So you change it to 1 over cosine B. Okay, then all you need to do is get the cosine ratio from here for your triangle. So we know that cosine is what? Adjacent over hypotenuse, right? So now adjacent, so 1 over, okay, now adjacent is a -2, then hypotenuse is square root 5. So cosine B is -2 over square root 5, right? So if you just flip the ratio, then you get square root 5 over 2. So this will just be your answer already, right? Okay, then part 2, you have cosecant B. So we know that cosecant is 1 over sine B, right? Okay, so once again, you can get your sine B from the diagram. So sine is O over H, so 1 over root 5. Okay, so over here, you just have 1 over root 5. Okay, so you will get root 5. Okay, so just like this. Okay, then part 3, we want cotangent B. So cotangent, if you recall, is 1 over tangent B. Okay, this one you don't have to look at your triangle actually, because tangent B is originally given in the question already. Okay, but if you look at your triangle, you should also still get back the same answer lah. So negative half. So you just put 1 over negative half. So that will give you -2. Right? Okay, so I hope that through this simple question, you should be able to recap some of the main ideas behind the trigo ratio. So namely, how to identify which quadrant the angle is in. Okay, how to form the triangle and find the third side. So just now, for this question, we were given the opposite over the adjacent. Then we need to use Pythagoras theorem to find the hypotenuse, right? So sometimes you may be given sine. That means you know opposite and hypotenuse. Then you should be able to find the adjacent side also, all right? And so on. Okay, so not too difficult of a question. So let's take a look at the second question, which is more challenging, all right? Okay, so question 2 goes, it's given that A is a cube. So A is a cube means 0 to 90, right? So in the first quadrant really. So this one is in the first quadrant really. Okay, so first quadrant. So in this question, we are directly told A is in the first quadrant. Then cosine A is equals to x, right? Okay, so this question is more difficult because this is not a number, but it's just x. And x is just actually x over 1, right? Okay, so Kumar says that sine 2a is greater than 0 and cosine 2a is less than 0. So do you agree? Then they want you to explain your answer. Okay, so for this question, to find out whether a trigo ratio is positive or negative, we need to know whether this angle, right, which quadrant is it in? Okay, if we know the quadrant is in, right, then we will know that whether that ratio is positive or not. Okay, because of the ASTC, right? Okay, so it's 2a. So now we need to know whether 2a is in which quadrant. Okay, so that we know whether sine 2a is positive and cosine 2a is it positive or negative, right? Okay, so we will start off by doing this. Okay, so A is acute, right? So if it's an acute angle, that means it's greater than 0 but less than 90. Okay, so what about 2a? So now we're going to times 2 to everything. So if it's 0 times 2 is still 0 and 90 times 2 is 180. So this means that 2a, which quadrant is it in? Okay, if it's 0 to 180, that means there are two possibilities. It's either in the first or second quadrant, right? So if you think about it, is sine 2a greater than 0 or not? Okay, if 2a is in the first or second quadrant, remember first or second quadrant, A, S, T, C. Okay, first or second quadrant sign will be positive. So this statement is correct. Okay, but how about cosine 2a? Is it less than 0? Okay, cosine 2a is more complicated, right? Because now 2a can be first or second quadrant. If it's first quadrant, then cosine 2a is positive. But if it's in second quadrant, cosine 2a is negative. So in other words, this statement is wrong, right? Because this statement says that cosine 2a is less than 0. But it could also be positive, right? If 2a is in the first quadrant. So this statement we will not agree with it. Okay, half of it is correct, but the other half is half wrong. Okay, because cosine 2a could still be positive, right? So we can write down answer. I do not agree. Okay, so they ask you, do you agree or not, right? Okay, so what we'll write down is sine 2a is greater than 0. Okay, since 2a is in the first or second quadrant, Okay, however, cosine 2a may not be less than 0. Okay, it will be greater than 0 if 2a is in the first quadrant. Right, so this is the answer. Okay, so we do not agree. Okay, the first part is correct. Sine 2a is definitely greater than 0 since 2a is in the first or second quadrant. But because first or second quadrant sign is positive. However, cosine 2a may not be less than 0. If it's in the second quadrant, it's less than 0. But now we can see that 2a could possibly be still be in the first quadrant. Okay, so you can think about maybe an angle like for example a is 30, then 2a will be 60, right? So it's still in the first quadrant. All right. So this is the solution for this part now. All right. Okay. Question 2b. Find expressions for each of the following. Okay, so for this question, we will now need to draw out the triangle already. Okay, so let's draw out the triangle over here. Okay, so now they say that A is a cube, right? So a cube means it's in the first quadrant. So this is A. Okay, so they say that cosine A is x, right? So don't have to worry. If they say cosine A equals to x, it also means that cosine A is x over 1. Okay, that means this will be the adjacent, this will be the hypotenuse. So in other words, so x will be the adjacent side. Okay, then 1 will be the hypotenuse. Okay, so if we use Pythagoras theorem to find the opposite side, okay, so this will be the opposite side, right? So opposite side will be square root of. Okay, now 1 is the hypotenuse, so 1 square minus x square. So you get square root 1 minus x square, right? So the opposite side is now square root 1 minus x squared. And it's going to be positive because this is the positive y-axis. Okay, so 1 minus x squared. So your triangle is over here already. So don't worry if they never give you numbers. You can still do, okay? Still form the triangle. Okay, so now they want tangent square A. So let's find tangent A first, then we just square it. Right, so tangent A. So tangent is opposite over adjacent, right? So it will be square root 1 minus x squared over x. Okay, so tangent square A will be 1 minus x squared over x, and you square it, right? Okay, so if you square the square root, you get 1 minus x squared over x squared, right? So this will be over x squared, yeah. So this will be the answer, right? So 1 minus x squared over x squared. Right, so next part over here, let's take a look at this. Okay, so sine 2a. So this means that we now need to apply the double angle formula. Right, so sine 2a. So if you recall, the double angle formula for sine is 2 sine a cosine a. Right, so let's get the value. Sine a will be opposite. So opposite is square root 1 minus x squared over 1. Okay, so since it's over 1, okay, maybe just write out, okay? Square over 1. Okay, then cosine A is x, right? So it's x over 1. Okay, so if you multiply, okay, the denominator will just be 1 times 1, so it's still just 1. So that means the final answer will just be 2x and then square root 1 minus x squared. Right, so you can see that once you get out the triangle, everything will be very easy to solve already. Okay. Okay, let's do part 3. So part 3 we have cosine 4a. Okay, so this is something we seldom see. Okay, let me redraw the triangle over here because we need to use it. Okay, so this is a. Okay, 1x and then square root 1 minus x squared. Okay, so now we want cosine 4a. Okay, so if we want cosine 4a, right, we need to use the double angle formula. Okay, do you agree with me that, okay, let's recap the double angle formula for cosine first. Okay, so cosine 2a will be 2 cosine square a minus 1, right? Okay, so now the angle is double of 2a, so it's now cosine 4a. Okay, so if it's double of 4a, right? If the left side is double, has been double, all we need to do is double all the angles in the double angle formula. So if cosine 2a is 2 cosine square a minus 1, cosine 4a will be 2 cosine square 2a minus 1. So we just double every single angle, right? Okay, so let's start with this question. So cosine 4a is 2 cosine square 2a minus 1. Okay, so now let's try to find the value of cosine 2a, and then we sub inside over here. Okay, so let's do it. Okay, so we will do it over here. So cosine 2a is equals to 2 cosine square a minus 1. Okay, but we know that cosine a is x, right? Okay, actually it's given based on diagram adjacent over hypotenuse. So this will be 2x squared minus 1. Then now we take this 2x squared minus 1 and sub inside here, because this down here is cosine square 2a. So it's 2x squared minus 1 square 1, okay? Okay, because cosine 2a itself is 2x squared minus 1, then there's a square here, so that's why there's a square here. Okay, so all we need to do is expand this one, and we should be able to get the answer. So 4x squared, 4x4, okay, over here 4x4, okay, minus 4x squared plus 1 minus 1. Okay, so we'll get 8x4 minus 8x squared plus 1. Okay, so this will be cosine 4a, right? Okay, then part 4. Okay, part 4 we have sine half a. Okay, so whenever you see a half angle, you always need to think of the double angle formula, and then you half all the angles in the double angle formula. Okay, so what do I mean by that? Okay, but whenever you see you are asked to find the value of sine half a or cosine half a, right? You use the double angle formula for cosine. Okay, so cosine 2a equals to 1 minus 2 sine square a. Okay, why use the double angle formula for cosine? Because if you use the double angle formula for sine, you realize that you have a problem. Okay, so double angle formula for sine is this, right? So if I want to find sine half a, so I need to half all the angles, then I will get this. I half the left side, so I will half the right side. So you see the value that you want to find is here, but then now you introduce a problem. There's a cosine half a again on the right side, which we don't know the value, right? So use the double angle formula for cosine instead. So cosine 2a is 1 minus 2 sine square a, right? So if I half it, I will get this. So if I half the angle here, divide by 2, right, the angle, then the angle here also divide by 2. That's why it becomes a half a. So now all I need to do, I only have one unknown. Cosine a I already know is x, so I can sub x and then I manipulate, I can find one sine half a already. Alright? Okay, so that's basically what we are going to do. So cosine a is 1 minus 2 sine square half a. Okay, so cosine a is x, right? Remember? So you put x here. Okay, then we just manipulate a bit, then we should be able to find sine half a. So 1 minus x, right? So divide by 2. So it's 1 minus x over 2. And then we'll just square root. Okay, if you square root, you may think that there's two answers, right? Plus, minus, correct? Like that. Okay, but if you think about it, a is a cube. So half a will definitely also be a cube. If you half an acute angle, it will still be a cube. So if it's a cube, then sine should be positive. Okay, in the first quadrant, the sine ratio should be positive. All the three ratios are positive. So this answer you will need to reject. Either you reject, or actually you can totally don't write at all for this question. Right? So the answer will just be this one. Right? So this is how you do a question like this. Okay, so do remember, if they don't give you any numbers, okay, you don't need to be afraid. You can still be able to form your triangle. Right, so I hope that this video going through a trigo ratio has enabled you to recap some of the concepts related to it. Right.